وبركاته، وأسعد الله صباحكم بكل خير. أتمنى أن تكونوا قضيتم ليلة سعيدة في الإسكندرية بهذا الجو الرائع والمناظر الخلابة على شواطئ البحر المتوسط. ونحن اليوم في اليوم الثاني من هذه الورشة الخاصة بالأمونيا واليوريا والNPK. الورشة لها أبعاد كثيرة ومفيدة، وأنا أعتقد شركة كاسale بذلت جهود جيدة وكبيرة لأن تكون الورشة بهذا الشكل المنظم والمنسق، وأنا أعتقد أن ما أتوا به من معلومات سيكون نافعا لنا في شركاتنا. وأيضا قرر أن هناك حاجة لأن ننقل هذه المعلومات إلى شركاتنا. معظم شركاتنا لم تتعامل كثيرا مع هذه الشركة العملاقة، ولهذا تعريف هذه الشركة ضرورة كبيرة. الأمر الذي دعانا لأن نأتي بهذه الشركة، سبق لنا أن أتينا بشركات ذات الخبرة وبيوت الخبرة الكبيرة الأخرى، والتي أقامت مصانعنا سواء في الجزء الأفريقي من الوطن العربي أو في الجزء الآسيوي من الوطن العربي في الخليج أو في المغرب. لكن اليوم في هذه الشركة الكبيرة نستطيع أن نقدم لشركاتنا أفكارا جديدة في تطوير مصانعنا. وأنا أقول كثير ممن يتحدث عن زيادة الطاقات في المصانع، هناك طريقين: إما أن تبني مصنعا جديدا ولا expansion أو أن تذهب إلى الريفامبينج بعد الرهاب. ووجدنا من خبرة كاسale أن مشاريع التطوير والتوسيع للمشاريع بطريقة الريفامبينج هي أكثر اقتصادية من بناء وحدات جديدة مكلفة وتضيف أعباء مالية كبيرة جديدة على شركاتنا. ولهذا أنا أدعو عند عودتكم بالسلامة إلى شركاتكم بمراجعة إمكانية تطوير شركاتكم. نحن في الاتحاد العربي للأسمدة نحاول أن نقدم ما نستطيع بالاتصال والتواصل بين شركاتنا، وهذه العملية تتم بأشكال مختلفة، منها إقامة الأحداث بالملتقى ومؤتمر فني أو الورش، والطريق الآخر هو عن طريق اللجان والمجاميع التي شكلناها حديثا. فبمجال الانرجي سيفنج أو السلامة هناك ستجدون إمكانية كبيرة من خلال المحاضرات بعمل أعمال كبيرة في مجال الانرجي سيفنج. نحن الآن نقوم بتجربة جديدة في مجال الانرجي سيفنج لترشيد الطاقة، وهذا المجال هو محاولة نقل المشاريع الناجحة والممارسات الناجحة في مشاريع ترشيد الطاقة من شركات نفذتها ووفرت ملايين الدولارات. ما نقوم به نحن، شركاتكم تستطيع أن تحصل فري اوف تشارج على هذه المشاريع بدون مقابل، وبالتالي نؤدي إلى وفرة كبيرة وتوفير في هذه المشاريع. في مجال الصحة والسلامة أيضا لديهم خبرة كاسale في هذا المجال. نحن قمنا بتقديم أول 3 أعداد أو 3 كتب في مجال الجود براكتس NHSE، وهذا حقيقة كان مهم وأتمنى على كل منا أن يقرأ هذا الجود براكتس وأن يحاول أن يأخذ منه إلى شركته، لأنه قد تكون الشركة متميزة في الجسم لكن قد فاتها واحدة من التجارب في المغرب العربي أو في الخليج، وهو في المغرب في الخليج أو في مصر، فاته أن يأخذ تجربة جديدة. فستجدون في 3 مجلدات، أحمد عندك المجلدات ال3 مال هذا إذا ممكن تجيبها، في 3 مجلدات. I'm sorry I'm talking in Arabic. في 3 مجلدات تتحدث عن الخبرة هذه. الآن احنا بنقوم بنفس الإجراء ولكن في مجاميع أخرى. لدينا كما تعلمون 6 مجاميع. مجموعة الصيانة والتشغيل وهي مجموعة مهمة، والآن احنا نعد كتيبات خاصة بالجود براكتس and operation and maintenance. This is a good practice and HSE. One is belong to SAFCO, the others belong to GPIC, and many other companies are participating in these books. ولهذا أشجع أن تقرأوا هذه وأن تشاركوا في هذا العطاء لسببين. الأول أن أنت تحصل على شيء من المقابل، وأن تعطي، أن تكون give and take win-win base العملية. فتعطي مشروع من مشاريعك الجديدة، تضعها في كتاب، توثقها لنفسك أولا، ثم توثقها لأشقائك العرب الآخرين من الشركات العربية الأخرى. وبهذا يكون الاتحاد العربي للأسمدة قد أدى جزء من رسالته في عملية نقل المعلومة بين شركاته الأعضاء. لا أحب أن أطيل ولكن أقول أن فرص العمل مع الاتحاد العربي للأسمدة كبيرة، ولدينا كم كبير من المعلومات موجودة على موقعنا، وموقعنا الجديد سيصدر قريبا أيضا، وسيكون لدينا موبايل ابلكيشن، وبإمكانكم أن تحصلوا على كل هذه الأوراق من مواقعنا. ونحن قد طبعنا كل المحاضرات على فكرة موجودة بشكل هارد كوبي وسوفت كوبي في الاتحاد العربي للأسمدة. أشكر الجميع وأتمنى لكم التوفيق وبارك الله فيكم، والسلام عليكم ورحمة الله وبركاته.
Good morning to everyone, welcome, and I'm very pleased to see so many faces again today. I hope you had a pleasant stay here in the beautiful restaurant. Well, in our second day of this workshop, we will focus, more interesting for you perhaps, on case history, case studies, where we will discuss practical application of the technologies we described today. We will start with Mr. Stefano Iov, who will talk about ammonia plant.
Good morning, everybody. As mentioned by Luca, my presentation covers the what we analyzed yesterday, the M2U08434 process scheme in a practical application in an ammonia plant we have just recently completed and started up. It is the 2050 metric ton per day natural gas-based ammonia plant, which we have licensed in Iran to Shiraz Petrochemical Company. The project is a grassroots ammonia plant designed and licensed by Casale, and the main contractor was a local company, Iranian company based in Shiraz, which is BIDEC, and the plant is in operation since mid-2016. Casale is the licensor of the plant and is the second plant of this type in operation in Iran. The first one was Razzi plant. PDEC is the main contractor, the EPC contractor essentially, responsible for the detail engineering and the procurement and the construction at site. PDENCO is the owner, the Iranian state-based company is the owner and responsible for the project coordination and project management of the plant. And the end user was Shiraz Petrochemical Company, as mentioned. As analyzed yesterday, the plant is a A2000 scheme designed by casale. So we have seen yesterday that it is a proven scheme. It is improved to make it more efficient with the casale proprietary equipment in the key section of the plant. So the plant is very simple and easy to operate, and the simplicity of the scheme brings to have a plant which is also cost effective, minimizing the cost and the capex of the plant. The energy consumption we have seen yesterday, this is a proven number, so it's not only calculated. The energy consumption of this plant in the test run was 7.15 gigawatt per metric ton. We will analyze briefly each section of the plant, just to show you quickly how our plant looks like in a practical project. The first section is the feed gas heating and desulfurization, heating in the primary reformer section, in the convection section, then the usual hydrotreater and the lead leg configuration for the zinc oxide beds. This is the picture showing the hydrotreater and the two zinc oxide beds. This is the primary reforming section, fully designed by Casale, and the thermal rating as well is according to Casale design. It's a standard, we would say, primary reformer with the steam reforming temperature at 800 degrees C and mixed feed preheating at 520 degrees C. Steam to carbon ratio as low as possible, lower than 3.0. This is the picture of the primary reformer installed in Shiraz. Process air compression as well, followed by the secondary reformer. Secondary reformer is, as we said yesterday, equipped with Casale patented secondary reformer burner, which is shown in the picture here on the right. The top, the neck of the vessel is the seat of the secondary reformer burners. Shifting with the axial radial design, as we discussed, CO slip as low as 0.35%, and the heat recovery system in this shifting section is used to produce steam at very high pressure. And these are the two vessels for the H and LPS. The CO2 removal section is based on the MDA system. The slip was slightly higher than 300 ppm, and the purity of the CO2 we give to the urea is above 99.3. And these are the two columns, absorber and regenerator for the section. Detonation section, nothing particularly to highlight. And the syngas compressor, as we discussed, our let's say scheme envisaged the installation of the ammonia washing section in between the stages. So you insert liquid ammonia here to dehydrate the makeup gas. As a side effect, you have a very low temperature here, and so you get a benefit in the efficiency also of the compressor second stage. Because working at lower temperature, the compressor has higher efficiency and less energy consumption. This is a picture of the compressor house. Synthesis loop is equipped with our, let's say, brand 3-bed 2-interchanger converter. The pressure of the loop is lower than 160 bar, and we are talking about 2,050 metric ton per day, and the conversion is around 20% of ammonia. And just to give you an idea, the catalyst volume is approximately 120 cubic meters. And this is the picture of the converter with the startup furnace. And as you can see also in this plant, we have the direct connection. From here you have an outer perspective. This is the vessel, and this is the boiler directly attached to the outlet nozzle of the pressure vessel. What we call the big foot. From here you can see why the name. So this is a graph we already saw yesterday, the standard A2000 process scheme, enhanced with the proprietary equipment by Casale in the key sections of the plant. We have talked at length yesterday about this. A couple of words about project execution. The contract has been awarded in 2007, and we have completed the design, the basic design, in the same year. Then, up to, let's say, plant startup and continuous operation has been some years, but you can understand the issue in Iran was not due to any failure of Casale or the EPC contractor, but it has been a challenging task to complete an ammonia plant like this during the sanction and blockade, and it has been quite a challenging task. So the Casale responsibility in the project was the licensing and basic engineering package and proprietary equipment, as we said, but we had a huge and extensive check and approval of the detailed design because of the importance of the project, and because we, as an approach, Casale always feels responsible for the project, so we want to assure the smoothness of the execution. So we are involved even in stages where a licensor could be less, let's say, involved, but we want to assure the proper execution. And of course, we had a team supervising during the construction and commissioning phases. PDEC was, as I said, responsible for essentially the EPC phases, so the engineering, procurement, and construction of the entire complex. And this is a picture taken of the team, where there is our colleagues and the PDEC process and engineering team. Our check in the detailed design particularly was careful in this section for the compressor, for the heavy-duty pumps, all the high-pressure vessels and equipment. As I said, the primary reformer, we followed closely all the procurement of the primary reformer, which is very critical, and CO2 removal columns, piping, high-pressure piping, and also the critical instruments. During startup and test run and parameters optimizations, of course, we were present, and we also executed a careful operator training, both in a similar plant, different plant, and both on site. So what this case study shows is that Casale is nowadays a reference licensor for the ammonia technology. We have on stream two 2,000 metric ton per day plants like this, both in Iran, and we have under execution other three currently, which will coming up in the next years. We also have shown a close cooperation with local contractors. What we feel important for a company like Casale is to develop a close relationship with local contractors, especially in the Gulf area, in this area where there are capabilities for the companies. We do not impose that the works are at majority executed abroad in our company or in Europe. We develop relationships in order to keep local content of the job as high as possible, given the quality and the reliability of the project that should be executed. So this concludes the presentation, and I leave the stage to my next colleague. I don't know what Luca wants to introduce or. Sorry. I was hoping to speak.
Thank you
Not so
for
lucky.
excellent presentation, Phyllis. I note the scheme of casale. You install ammonia washing unit.
Yeah.
Yes, in the central stage between central stage to the compressor. This ammonia washing unit is installed in the recycle, in the recycle gas, or what?
No.
And also, what is the purpose for this interstate washing ammonia unit? And also, what is, you depend on water or what?
Okay.
For washing, and also if you depend on water for washing the ammonia.
Okay.
What is the side effect of carryover of ammonia with the gas to enter to the converter and the effect on the catalyst?
Okay.
Thank you.
Clear. I'll start answering, and then maybe Fabio can go into more details if needed. The ammonia wash is installed not on the recycled gas, but on the makeup gas. So here we have the gas coming from the metanator. It is compressed in the first stage. So we are around, if I'm quoting by heart, so we are around 60 bar in this area. We take ammonia, which is pumped back from the back-end section. It is taken already in pressure during in the high pressure separator, but there is also a pump envisaged in case it is needed from lower pressure. So we have ammonia here. For a 2,000 metric ton per day, we need around 15 tons per hour of ammonia. And this ammonia is contacted in this ejector with the makeup gas. And here we have an intimate contact between liquid ammonia and gas, so we are able to remove all the water and the oxygenated compounds, which are then, the ammonia is sent back from here to the back-end section, to the refrigeration section at the appropriate pressure. And here we have a makeup gas which is free of oxygen. It has, of course, it is in equilibrium with ammonia. And it is in equilibrium at the 60 bar, so the temperature is low. I don't remember exactly the value, but it's even below zero, I think, around here. So this section of the compressor is very efficient. Then here, from here, you don't need to the syngas and the makeup gas are mixed here. So you send directly the makeup gas to the inlet of the converter. You don't need to feed the makeup gas to the chilling section to go here and go back. So you save energy in this chiller, basically. You have, of course, as you correctly said, an impact on the catalyst, on the efficiency of the converter, because you have more ammonia than you could have. But again, the efficiency of our reactor can perfectly withstand with this fact. So yes, you have a slight impact on the conversion, but thanks to our ammonia converter, you can perfectly cope with this. But the overall gain is an energy saving of the roof.
Okay. Question?
I want to know the steam consumption figures before and after installing the ammonia wash ejector.
That is a little bit more difficult. Yeah. In a revamping case, our ammonia wash system historically have shown an energy saving of about 60 to 80,000 kilocalories per metric ton. This is the average energy saving that we have seen in the installation during a revamping, because this has been done since the beginning. So the plant has been designed and conceived with this, but we also do revamping with ammonia wash. And the energy saving is about 80,000. It's not much, but you have to consider that this is a very cheap modification. You just need to install an injector, which we have seen. We have seen the picture. Yeah, it's a simple injector. You have to install a small separator, or maybe probably the separator you can cope with the existing one. And depending on the design of the compressor, you might need a filter for the oil, maybe, depending on the compressor type. So it's very cheap revamping, and you get 80,000 kilocal per metric ton of saving.
After absorbing this ammonia from the separator for carbon dioxide and the carbon monoxide, which are carried over towards the gas, the syngas outside the makeup, it will have a side reaction from the carbonates, and this will be ammonia produced with a carbonate and some side reactions inside the separator, inside the ammonia. How we can, the route of the ammonia, it will be go to another sections from stripping, or will go to the ammonia product to the tank, ammonia tank.
No, this ammonia here will go directly to the tank. There are, I mean, the percentages and the at stake are very limited to have this side reaction. So the ammonia will be sent to the final product, because at the end, I mean, you are realizing here what you would in any case realize in this one. Because in a standard process, you have the makeup gas going here, and the ammonia, the liquid ammonia, is taking out all the CO2 limited amount, all the water that you have before leading to the reactor. So in any case, all the gases that you separate in our ammonia wash, you would in any case have in the liquid ammonia product. So there are no differences in that.
Last question. If we have another two bed from zinc oxides after the desulfurization technique, we have solar chromium and we have two bed from zinc oxides, swing reactors.
Yeah.
We like to change another reactor from zinc oxides to pre-reformer section. We can do that or not?
You mean installing the, pre-reformer section is not in place of the zinc oxide beds. I mean, you install the pre-reformer still after the zinc oxide beds. You need those beds to remove the sulfur contents, and you cannot have the pre-reformer in place of these two legs. Okay, thank you.
We need to know also the same subject. We need to know the percentage of ammonia in the makeup gas after this ammonia washing unit, and the effect for conversion. What is the conversion ratio in the ammonia converter?
The percentage of ammonia, the number I need to check. If I recall, I go by heart, but it's long time ago since I saw this. It's higher than 3% for sure. The inlet of ammonia here. I need to check. I have the balance of Shiraz. I will then check in my PC and give you the number.
Also, you need to know the percent of innert accumulated in the loop, and if any oil leakage from the compressor will directly feed to the ammonia converter.
Exactly. As I was saying, when it depends on the design of the compressor. If it is a dry seal compressor, that's exactly no problem. When we revamp existing plants, which are typically also quite old, so there is a standard sealing system with oil, we install an oil filter up here, or I don't remember, here I think, downstream the separator. We install an oil filter with coalescer, so it's preventing problems in this section. So we know exactly the issue, and it's a way to solve it. We have installed in several plants, so there are a possibility to visit those plants.